This is the web app that we are going to deploy on AWS using GitHub Actions and Docker. So for the trial, if we open this app, now the app should be able to recognize if the patient has pneumonia or not using this X-ray image. So if you say predict, it should detect that the patient has pneumonia. If we upload the image of a normal person, it should detect that it doesn't have pneumonia. So this is how our web app works, the project structure, and what are the files that we are going to use. So first file will be the setup.py, which has the description about the project and basic information that is required after the project is running. The second file will be the template.py. When we run template.py, all the basic structure of the project gets created on your system. In params.yml, we are going to save all the parameters that are required while training of the model. The next file is configuration manager. The job of the configuration manager is to create directories that are required in the artifacts folder. It configures every single directory or every single file. It has addresses to where the data is ingested and where the model is saved. The next part is component section. In the component section, we have all the components or all the functions that are required while the process of the project. The first file of the component section is data ingestion file. In the data ingestion file, we have functions where the download file function downloads our data set, which is stored as a zip file, and it extracts that zip file into our artifacts folder. The job of the prepare callbacks is to store the checkpoints or the logs while the model is being trained. I have this file, but I have not added this file in while we are training the model, but you can use this. The first component of training is get training data, wherein we are converting the image into an array and we are resizing the array into 150, 150. So whatever may be the size of the image, it will get resized to 150, 150. The next function is process data, wherein we are dividing the image by 255, which is a standard process. Process data helper is used for separating the X and Y, that is separating the image and the label. Next function is of data augmentation, wherein data augmentation is used to generate more data than what we have, so that we have more data to train our model. The next function is our model. In this model, there are 22 layers. 5 are convolutional layers, 5 are patch normalization layers, and the remaining are the dropout layers, the flattened layer, dense layer. This model has given us a 91% accuracy for our project. The next is that we save our model, and the next is train model, wherein we have some of the parameters that are required while training, like the learning rate reduction. So what we are using is that if I have 0.1 as a starting learning rate, it will get reduced and reduced as the accuracy is increasing or as metrics has stopped improving. The next parameter is class weights. We have used class weights because we had more images of pneumonia patients than normal patients. So the model may have been kind of biased, so class weights is helping us there. And the other parameters we are calling like image and batch size. The next part of the project is pipeline section. What happens basically in pipeline is that every single component runs step by step. So in the data ingestion process, when you will run this file, the data will be ingested in the artifacts, it will be extracted. Then next in the training session, the data will be processed and the model training will be done. One more component of the pipeline section is the predict file. We run predict our file when someone uploads an image on our app, and it will process the image, convert it into array, divide it by 255, expand its dimensions, and then run our model, load our model, and predict whether the patient has a pneumonia or not. The next file will be main file, where we run every single step by step. So this is basically our training part. The next part is the deployment part. In the deployment part, what will happen is our code, after getting pushed to the GitHub, the first file that will run is main.yml. main.yml has all our code of CI/CD. Here is all the code that is required to configure AWS through GitHub Actions. After that, Docker image will be built and it will be pushed to ECR. Then in the deployment section, that same image will be called back and it will run all our project on the EC2. After our Docker image runs on EC2, the first file that will run is our Docker file. So after Docker file runs, it will create a Python image, then it will install the required system dependencies. On here the most important dependency is AWS CLI. Then it creates a work directory app for us. Then it copies the application in that directory. Then it installs all the requirements for us. It exposes the 80 port for us. Now that we have deployed all our app on port 80, that's why we need to expose our port. And after that, it will run the command python3 app.py, which will run our app Flask app. So this is the code of the Flask app, wherein we have given it basic commands. After app.py runs, first it will render our index.html, that is our basic web page. And when we have to train the model, we can also train it after it is deployed. And the third prediction part is that when someone uploads the image on the website and we predict, then this third part will run and it will predict the answer for us. So this is basically the project part of it. This is how CI/CD will look in your repository. All the three components have been successfully run, and these two first sections, they have been first run on the GitHub Actions. They have built the image and then they have sent this image to ECR, and then this deployment section, this was run on the EC2. This is what something it looked like when the configuration of GitHub Actions and EC2 was done. Now how to set up this connection, I have shown this in my repository. You can copy that. For that, you will have to handle two settings in GitHub. That is, you will have to create a self-hosted runner. After you go to your repository, in action section, there is runner section. Here you can create your new self-hosted runner, and in the secrets section, you can set up your secrets, which are required when the main.yml file runs on the GitHub. So this is how our CI/CD pipeline looks like, and this is how our project looks like. You can copy this project using my repository, and if you need any help regarding this project, you can contact me through my LinkedIn. Thank you.